In this exercise, we're going to solve the following problem. So given a tank that has the shape of a cylinder, okay, that can hold an amount A of water. So let's assume A is in gallons, okay? So to drain this tank, we're gonna use the following model. So if we assume that Vt is the amount of water at the cylinder at time t, so let's use this one, A times 1 minus t over big T. Big T is the total time to drain the tank. So big T is small t is between 0 and t. So let's say big T is 60 minutes, 24 minutes. Big T is fixed, and the small t can change. Okay, so this is the time changing, and this is fixed. Okay, so the amount of water Vt is depending on time. So the question that we're gonna ask here is, what's the amount? Let's graph this one to see what's happening. It's a very simple model, but it's good to know. So what's the amount of water when time is 0? It's A. We haven't started this is Vt, this is T. So we haven't started the process of draining the tank. So what's the amount of water? It's A. When we finish draining the tank, that will happen at what time? At time equal t, big T. So let's say this is our big T. So what's the amount of water there? Nothing, 0. So the amount is here. And we can see from here that this model is a negatively linearly related model. Okay? It describes the relationship between the time and the amount of water left in the tank. Okay? And we see that it's linear. And the equation also tells us that it's linear. This model, it's not describing the nature of the matter, because we don't see when we have a hole in the bottom of the tank, we don't see the water doing this way, changing in this manner. That means it's changing linearly, but it's negatively proportional to the time. It doesn't happen. But we are using this model to see what can happen. Okay? According to our model, what can be the amount of water left in the tank after half of time? So when we start at 0, after we reach half of time, what can be the amount of water left? So we can answer this question without solving anything. So the amount of water should be half of the water. It should be A over 2, and the time should be T over 2. Okay, because it's linear. Every second there is some change. Every other second the same change happen. We lose a quantity in every second. The same quantity is lost in every second. Okay, so there is no changes happening, or there is no change happening suddenly. We see the same change every minute or every second. Okay, to answer this question, we need to say, what's the amount of water? What time will have half of the water left in the tank? So that means we need to solve Vt is equal to A over 2. That means at what time the amount of water will be half. And since we have Vt, we can say A is 1 minus T over T. It's A over 2. We can cancel by A over 2 because it's positive, and we have 1 minus T over T is 1/2. and we add 1 to both sides, minus 1 to both sides, we get t is equal to t over 2. And that's what we get here. Okay, so this model, it's describing the nature of our problem, but it's not completely or physically describing, because there is a sort of some power that's applied on the particle of the water. So this model doesn't really describe the situation. There is another model. If we let Vt equals a1 minus t over t squared, t everything square.